Thanks everyone for coming. I'm actually not from London. I'm from Seattle. Just a quick check who are from London. And okay, there are many actually not from London. So yeah, thanks for coming from all over the world. So today we'll discuss about AI agents. We will have an introduction to the AG2 open source AgentOS. We'll have hands-on code, and Tim will show you some very interesting example applications. Here's the agenda. I will first make a very brief introduction about the AgentOS, AG2 key concepts, and so on, and maybe some of the latest progress. And then we'll cover a number of interesting applications. You can try them on your laptop. And here's a QR code on the screen. If you scan it, you will find a GitHub repo called Build with AG2 under the AG2 AI organization. There are many example projects in that repo, and today we'll cover several of them. I guess we will have enough time to also take questions from the audience. So you have specific questions about specific features or functionalities you want to implement and don't know how to do. We can take that and show you maybe from documentation, or maybe we already have examples in our documentation. There are a lot of rich functionalities, so we're not going to cover all of them. So I'm sure there will be questions that's not covered by our examples. But hope you can enjoy the session. And if you ever tried the QR code, can you let me know if you can open the repo? If not, we'll help you figure it out. Good, everyone good? Okay, awesome. You can feel free to browse the repo. If you feel my talk is boring, you can feel free to browse it on your laptop. So I will begin with some really quick introduction about this project and what I'm trying to enable. So basically, 2 years ago, I created an open source project called AutoGen, and the motivation was that we observed the power of generative AI technology, and I was thinking how to maximize the power of these language models and make really useful applications on top of them, and how to empower all the developers to do that. We made the early bet that agentic AI will be the future, and we want to build applications with these several dimensions. First, we want them to have a natural interface, so they can take humans' input in a very natural way, and we can talk to them. And then they can execute the very complex tasks on behalf of the human with strong capability. And these two are easy to understand, but I thought even one step further about if we can create these type of agents in future everywhere, you can not only use them separately, but also connect them together and build even stronger systems. Then they can solve even more complex tasks. And that can also fundamentally change how we build software in future in an agent-oriented programming way. So that's a brand new programming paradigm, and that's made me excited. And I want to make the agent a useful architecture and center all our ideas about how to build applications around these agents. And to achieve that goal, it's very hard. At that time, there was no very good framework to use. So I decided to build one. And the reason is that I want to simplify the developers' thinking process to think about these AI agents and make it very easy to reason about these different type of components like language models, tools, and humans, and so on, and make one intuitive agent abstractions for all of these different type of components. And then we can simplify it to think about just how to orchestrate these multiple agents together to build the application. And we want to enable very advanced exploration and enable all the diverse applications on top of that. And to do that, we also need to provide the common infrastructure, common components that are reusable. Even though it has evolved so much in the past 2 years, the basic essential concepts are very, very simple. I can simply describe that in one slide. So we want developers to think about any arbitrarily complex applications in simply 2 steps. The first step is to create the agents that are customizable, that have different roles. And the second step is to make them to talk and get them to solve problem together. As simple as that. So here there are two key concepts. The first one is called conversable agent, and second one is called conversational programming. The agent abstraction here is very generic. It can unify several different types of entities like language models, tools, or humans. So each agent has the same interface to send messages, receive message, generate replies using some particular backend. And the only difference is what kind of backend they use to generate reply. But on the surface, they all work similarly. So that makes it very easy to reason about them and connect them in a unified way. And for the backend, you can use language models to generate reply, or you can use tools that's not the language models, or you can use a human behind agent. So these are the three primitive type of capabilities, building capabilities you can directly use or mix. But how do we construct even more capable agents? And the answer is we could first create these simple primitive agents, and then we can get them to talk and use all the different building conversation patterns or your customized conversation patterns to make them perform stronger tasks together. And you can do that also recursively. Once you have a strong agent that goes beyond the primitive, you can further connect them with other even stronger agents and create more and more advanced agents in this way. You can do that recursively. And the type of conversation patterns you can choose are several different kinds. Some of them are more deterministic, like the sequential chat. You can specify a predefined sequence of conversations, and the later one will begin only when the previous finish. And you can also construct more dynamic chats like a group chat using either fully flexible conversation order or can define certain type of handoffs to specify when to translate from one agent to another. And you can do that in both natural language and programming language very flexibly. And you can also use nested chat to do the recursive wrap up of several simple agents wrapped under more complex agents and further wrapped up under even more complex agents. So nested chat is a natural way to connect multi-agents to a single agent. So that's basically the key concept, and those building blocks can be used to compose many more advanced functionalities and more complex systems as well. And there's also a lot of common capabilities that people ask, and here I want to mention a few. For example, we have the building code execution support. You can execute code in different environments. You can also have building human in the loop conversation. So you can easily have a human in the loop, even multiple humans in the loop if you want. And there's advanced tool usage. Tool usage is very important for the agent to perform advanced tasks. So we can, in AG2, it's quite flexible. You can have one agent propose the tool use and have some other agent to just execute that agent. Execute the tools, or even have more agents to review the proposed tool and not execute if they're not good enough. And you can have advanced patterns like allow secrets to be used together with tools, but provide no secret to the language models. You can hide certain kind of dependencies from the language models, and so on. You can use model context protocol and the MCP protocol to connect to other MCP servers. You could interoperate tools from different libraries as well. And this gives you a way to easily extend the capability of agents. Sometimes even a single agent can do very specific tasks like browsing the web, for example. And when a single agent is not good enough, you may want to construct more multi-agent systems, creating agents of each agent to just focus on a specific task so that they can be more reliable, and together they could achieve much more. We have some example like customer service support. You could construct a customer-facing agent to talk with your customers, but you have many others agents behind the scene to focus on more specific narrow tasks, like handling the orders, doing authentication, or managing the orders, and so on. And some of the agents can use the nested chat pattern, like the order management can have other sub-agents to help with even more specific tasks. But all the agents can have some shared context, so they can have context of both the conversation history and also other structure output in some structured variables. So for example, you can have the workflow context, some database that's shared by all the agents and all the database and so on. And this provides both kind of easy context management, shared context, and also easy handoffs. You can specify when to transit from one agent to another, like in this case, when to transit from authentication agent, when to do the order try agent, and so on. And some of the rules can be specified using program language, and others can be done in natural language. Okay, so that's basically the most basic kind of features and functionalities. And using them together, we can compose many advanced agents. We provide some examples in the library called reference agents, and they can be used already directly from the library to do some advanced tasks, and you can also use them as a reference point to customize your own. For example, the captain agent is an agent that can manage a library of agents and tools. And when the user uses the captain agent, you don't need to worry about constructing the sub-agents by yourself. You can simply ask the captain agent to solve the task for you, and the captain agent is able to either use some existing library of agents or construct new agents on the fly. You can generate a team of agents on the fly and revise the team in multiple steps. So that's a very interesting feature, and there's a lot more research we can do to make it even better. A real-time voice agent is an agent to allow some real-time communication in natural voice, and at the same time, it can work with a swarm of other agents behind the scene to handle all the specific tasks. The doc agent is good for processing documents from different sources, and web surfing and deep research agent can allow you to find information from web, browse web information, and do multiple steps of deep research. And there's also advanced reasoning agent and communication agent as examples. I want to just explain one example from the last slide. That's the deep research agent, and later we'll have also real examples by team. Here, the design of deep research agent is mainly using the nested chat patterns, and also leveraging some existing agent like the web server agent. So this is also example like how you could pile up the complexity by reusing existing agents and add a few more functionalities and enrich your functionality in a bigger system. Here, the deep research agent will answer a complex question like what was the impact of DeepSeek on sale prices and why. And after it takes that question, it will have a nested chat. First, have an initial team of 2 agents, one called summarizer agent and one called summary critique. The summary agents will further have other two agents as sub-agents. It will have a question decomposition team to decompose the task into some sub-questions, and also have a decomposition critique to challenge the answer. And the decomposition agent will try to get answers for each sub-question using the web server agent and web server critique. And so you can see it's several levels of conversations. The inner conversation will first finish and then return to the upper level conversation and further return to the upper level. And before the conversation finish and before the next chat finish, the current conversation will get on hold. So that can provide arbitrary kind of hierarchical design of a team, and you can go down really deep to solve a task. Yeah, later we'll show a working example. Yeah, so that's maybe just a brief introduction about the main functionalities, and also quickly mention a little bit about the history of the project. Before I got to AutoGen, I was working on another open source project for AutoML and hyperparameter tuning. So probably some of you have heard about this called Flamo. It's for like model selection, hyperparameter tuning that has started like 6 years ago. It's already widely used by like data scientists and machine learning engineers for choosing the models before the deep learning age and before the generative AI. About 2 years ago, I started working on the AutoGen and the subpackage inside Flamo together with Professor Qingming Wu from Penn State University. And we coded the initial version of AutoGen that supports multi-agent orchestration as the main functionality. And in October, we realized it's time to move it out to a standalone repo on GitHub. So that's the time we spin it off as an AutoGen project, and got a lot of attention and a lot of usage. and over time it received quite a few awards. And also we evolved a lot, and so about the end of last year we made another fork called AG2. That's a community-driven effort, and we all the founders and maintainers have moved to that new home to continue the development. So that's how the AG2 comes from a Flammo to a AutoGen and to its form today. Along the way, there are a lot of startup companies, enterprise companies, and also scientific use cases of AG2. And here are some small selection of the example production use cases. They span across many different domains. So I hope this also helps you understand what type of applications or domains can be so you can leverage AG2 to solve these tasks. There's agent platform. There's that's more horizontal kind of use case, and there are many other vertical kind of use cases spanning across finance, like autonomous trading, from business automation, chip design, customer support, even digital farming. Even some domains that are far away from the tech, and software development and software testing is a lot of activities there. Even healthcare, like patient support, marketing, investment research, and so on. So these are like examples how you can build vertical applications in many diverse domains. There's a QR code on this page that will direct you to one page in the website document in the document website for some example of the user stories and talking about how they use this library tool to solve some real problems. It's not complete, but we will add more in future. Hope you get a basic idea. And in the next section, Tim will come up and walk you through of some examples in the build with AG2 repo. So if you still have trouble finding it, please let us know right now, because we'll get to the hands-on part next. And if you have any quick question about the basic concepts, it's also a good time to ask now. If not, then there's some.
How does it compare to the recent framework used by Google? Agent development teams, right?
So ADK was released roughly about 1 or 2 months ago. It's in April, and it's probably most recent agentic SDK. It definitely took a lot of lessons from the previous frameworks. AG2 AutoGen is the first one, and there was some other frameworks developed also afterwards. And I think ADK took some learnings from them. I think one biggest feature for ADK is it has a good connection with Google Cloud ecosystem, and so if you already are using Google Cloud, you may find some very convenient ways to deploy your agents using ADK together with some other Google Cloud service like Vertex AI Agent Engine. By the way, Agent Engine also supports AG2 as one of the open source frameworks you can use. So it can offer some like session management, logging, telemetry kind of features on top of these open source frameworks. Yeah, thank you for the question. Yeah.
In your experience, is latency in hierarchical and larger multi-agent frameworks an issue? Mm-hmm. And if so, what are your best practices of dealing with that?
Yeah, this is a very good question. People often think that when we use multiple agents instead of single agents, we will inevitably have like higher latency, higher costs, and etc. It's actually quite surprising that it's the opposite. It can often be the opposite if you design your multi-agent system in a good way. And the reason for that is when you change from using a single model to build a single agent to building a multi-agent system, you have more freedom to choose the model for each agent. Think about this: if you have to use one single model to build a single agent that can solve all the different tasks you want to solve, the model is bounded by the most difficult task it needs to solve. Yeah, because you can choose only one model, you have to use the most capable model likely because will be some very difficult tasks that only this powerful model can solve. But now, if you think about multi-agent system, usually you will decompose the entire task into smaller pieces, and each agent only needs to handle a relatively easier task. And so also you can choose a different model for each agent separately, right? So that means for many of the agents in multi-agent system, you actually can afford to use a much cheaper model and also much faster model to solve a much easier task. But together, because you have multi-agent together, they could still solve the complex tasks. So that's actually one surprising thing that leads to this. Often I've seen a lot of examples that people use multi-agent design and they eventually achieve faster response and higher quality results actually using cheaper models than using a most powerful kind of model to build a single agent. I've seen successes in many different domains. Yeah. Thank you very much. Yeah.
Does framework itself provide some instructions for testing, evaluating, like if the system is behaving as we expect it to behave?
Yeah, that's also like a very good question. The evaluation of the agents is a big kind of fundamental building block that's required to do automated optimization, or if we want to kind of have this captain agent, for example, I mentioned earlier, to automatically learn about what kind of tools, what agents are most effective for one particular set of tasks and reuse them in future. This evaluator part is very important. So that's why in the captain agent design, there's actually one agent in the entire workflow that's in charge of like reviewing the previous steps of the agent previous team and think about what is missing and refine the team in the next step. And there are tons of examples in different types of reference agents. Captain agent is just one example of that. Reasoning agent also requires one grader agent to look at the current reasoning trees and pick the most promising thinking paths. And there's also the deep research agent. In the deep research agent, we see that there are multiple critique agents that need to be used to challenge the other agent's solution and try to refine them. So we can see several different types of agents that are used everywhere mostly in these applications, and they all serve the similar functionalities of doing evaluation, doing critique, and so on. There's so far, I don't think there's just one single agent that can do all the different types of evaluation all at once, but at least there are some examples you can refer to and maybe can learn from that. And we also have one experimental feature called agent eval in the library that's used to look at the logs of your agentic application or any language model-based application and try to come up with some dimensions to evaluate your application. You can just provide a task description, and the agent will come up with sub-dimensions to decompose the entire evaluation into a few different areas, and then do the assessment on how effective each area is. So that also provides more like a drill down insight automatically to help human to do evaluation. And most recently, we also did some research about how to evaluate a multi-agent system specifically, how to do the failure attribution. If the system fails, which agent should be responsible for it, and when did that agent make the first mistakes? We construct some benchmarks and we tried several approaches and found some of them are more effective than others. That's the most recent research work we did and will be presented at SNL and the Spotlight. Yeah. So there's still a lot more about research about the evaluation we can do, and that's a topic I want to further discuss with everyone. Yeah, thank you very much. Any more questions?
And sure, the framework connects with your standard LLM observability platforms, right?
Yeah.
It has like support for AgentOS.
Yeah.
Landscape.
Thanks for mentioning that.
Yeah.
So there's like a logging and telemetry feature for AG2 agents, and you can choose different type of like telemetry service you want. It has a built-in way of logging, and also you can choose to use some existing service provider like AgentOS, Arise, and open telemetry and so on. Yeah. You can also customize your own telemetry service, and those logging information will be very useful for evaluation. Okay, yeah, I guess Tim, it's your time to come up and do some fun demos.
Okay.
Thank you. Thank you, everyone.
Thanks, Chi. Sorry. Thank you. Okay. Give me a moment. That was a really good talk. I don't know. It's a lot of pressure if the guy himself that made the thing, you're following the talk from him, you know, and giving this demo. But yeah, thanks. It's been very nice working with Chi and the community and stuff. Very supportive. So the tough questions, he's there to answer. But yeah, we'll talk about, I think he said earlier, we'll cover some examples, Kaggle example. So for those, if you have access to the code already, you will have a bunch of, let's say, yeah, I'm going to try. Give me a moment. I think this one should be there. There you go. Yep. Just giving it a try. There. So in build from Kaggle, in build with AG2, this is what you'll see. You'll have the AutoML, automate ML for Kaggle, so two different things. Okay, what are we looking at? What are we going to see? Basically, Chir mentioned earlier some of the patterns, group chat. So we will see what that looks like in practice with custom speaker transitions. So I think, as he's mentioned, AutoML, the ML lifecycle, it's a very good example of state machine design, wherein the input is very distinct, right? Recap on that: when you build models, you do data analysis, data processing, and then model training or maybe experimentation and development, and then performance evaluation, and then deployment, right? So it's very interesting because actually you could start with that, like these speaker transitions, agent transitions. The way you could look at it is if you model them as, that life cycle wherein each segment of that process could be an agent that does a specific task. And one principle is actually like separation of responsibilities, standard software development stuff, right? The other feature that it has would be code execution. Chir mentioned that you have the conversational agents and you have agents that can run code. I think he's shown that some of these agents have built-in capability to execute code. Each agent could have their own context, models to execute their code. I think one of the gentlemen asked in terms of performance. So that's how you would gain the performance kind of optimization, I'd say, right? Like with monoliths, right? You're you're actually better off being able to optimize certain parts of a workflow when you have this disaggregated architecture. And the multi-agent framework would be disaggregated. Say, if you have one agent that just echoes or summarizes, right? You don't need a compute that is as big as or as powerful as a complex multi-step critique or code generator. So those are kind of some of the patterns to optimize them. If we have time, I'll try showing you how to run AG2 locally using Ollama. So when we're brainstorming, sometimes we were playing around with the idea that, okay, maybe there are certain agents that run on the edge, and then the tougher ones you throw to the cloud because you need GPUs. So that's how it's going to look like. So EDA, data processing, feature engineering, training, summarization, so on and so forth. Let's go. Just have a quick look. If I'm missing something, okay. Let's just jump into the code. So here you go. Something to note as you set up your project, your config. This is where you define what kind of LLM you're going to run your agents on. You could have multiple agents. I'm going to show you the Ollama config because that's how it would look like if you have a unique API endpoint. I won't show you my OpenAI one because it has my key. Different settings on how you configure your LLM. So you could have different agents that use one LLM and the other agent uses another one. It's another thing. So this is how it would look like, defining each one of those agents. So one wherein you're very verbose in terms of explaining what the agent can or cannot do, and this is like the unique conversational programming paradigm that was mentioned earlier. So here you can see here that it has one type of LLM config, and it can be another one for another agent, right? So this is, I think, where that disaggregated advantages you get, wherein there's also ways for you to run them asynchronously, the nested pattern. That's also another way to kind of lessen the latency or improve throughput of your job to be done of the agents. So very interestingly, so this one's the model trainer. It produces code. Let's kind of look at that. So here it says you're a model trainer given a data set that does blah. So we're capturing what let's say a data scientist or an ML engineer would do to build that model, and it will produce. So it will produce code, and I think in the pattern of reason, critique, reason, plan, critique, iterate. So there's a critique or criticize, or someone that evaluates whether what was produced works well. So if there's code that was produced that's gonna break, then it's meant to handle take it out from there. And then finally, you have your user proxy agent, which is a proxy for the end user being the one who has control over the machine, the one that executes code. So it's a proxy for you as a person that runs the code, but at the same time, you can set it to have human input or automatically just run the piece of code. So one thing one thing of interest is this Jupyter Code Executor. So wherein it's a stateful code environment or code executor where it's able to see the context or information that was produced on previous chats. Because if you don't have this, then it doesn't really hold context of what was produced by the previous agents. So this is how it would look like, the state transition. So you're able to set basically the sequential order of how things are handled, or how jobs are done, how information is passed. So that's practically what we're looking at here. And then, in this is just a sequential order. There are other features of the group chat where it has round robin. It can do round robin. It goes back to the start, and then there's an automatic assignment, which I'll show later, which passes the responsibility to the LLM to decide who goes next, which is very interesting to see, especially if you've not, if it's very vaguely written or prompted. You get some really interesting back and forth between agents. But yeah, so what this does is it just registers the agents within that group chat, and it tells the group chat manager that this is how you have to follow these sequence very strictly. And that kind of kicks off the task of what you're trying to do. So here we'll have a look at one of the hello world of data science, which is house prices, CSV. You can see there. Let us have a look. Okay. Okay. So we can see from the trace what's happening, right? So we said in the task as, please help me build this model, go through that sequence, produce the code, run the code. So that's what's happening here. So you can see it even produced the code that generates, plots the diagram, plots the charts of, say, if this was a confusion matrix. I have another example of a categorical, a classification model. If it were a loss curve, it will show that chart of the loss curve. So yeah, you could see here it goes through that reasoning of why this is a good idea. What are the best, it does feature selection or feature engineering, tries to understand which features are more important. So we can see here the separation of responsibilities between executor and summarizer. Okay. In the end, it produced this piece of code. Yeah. If I run that code as well, that will be just, okay. There's an error there. But what I can see here is it has executed and produced the output. So I don't know what's happened there. I'm going to give it another shot with another problem where.
Can I ask a question?
Yeah.
How do I run this myself?
You go to. I have here in the README like the steps on just installing the requirements and things like that.
So I've got that. It looks like it needs GPT-4.0 and a GPT key. Is it only OpenAI that you're supporting?
No. So it has multiple support for other APIs. So what it will look like is, so in if you go here, so here is where you define which LLM you'll be using. Actually, this is the sample. So you can define the model you want to use. For example, here I have DeepSeek R1 running on my Ollama. Actually, I can show you how that's going to look like. So actually have an Ollama running here. Ollama serve. Yeah. So this is the URL locally where what's going to happen is the agent will use this endpoint. Let's have a look what that looks like. Yeah, you can see there it says Ollama is running on top left. So if I use this config, what's going to happen is that it will use that. The only problem is I have a 16 gig Mac, I think, so it will be super slow. Not because of AG2, but because of just the LLM itself. It's gonna be slow. Yeah, I think 7 billion. I think it was list. Yeah, so it's a 1.5 billion parameter, and it's taking a little bit of time. I think 5 tokens per second on my laptop right now. But there are other ones. Like I think Gemma does pretty well, like the very tiny ones. But you kind of don't have the compute. It's not very good in terms of like quality, things like that. Of course, because you don't have that much compute.
I ran it with GPT-4 and it ran fine.
GPT-4 is fine. Yeah, that's good. Yeah, so the error on my side was probably something it's the demo gnomes messing up with my code. Yeah, so it's working. And let's see. The other things that I was playing around with actually a while ago is you can also, if you look at here, let's have a look. Well, on the task, like here I've told it don't use tree-based models. Actually, you can play around with why not use neural network. Of course, this is not running on a big GPU, so do it at your own risk. But this loss curve was actually with I think what's this? training loss curve. So this was like one layer, or four layers LSTM, something like that. Anyway, but it introduced that as well. Question before we go to the next bit, which is going to be fine. Yeah.
Is there some sort of way for us to improve our prompts to the agents? Is there a schema that we should follow that works better, or any guidelines?
Ooh, prompting tips.
Well, I read the prompts on the agents that you said, and they all seem quite specific in structure, like saying you are this and that. Now, question is there a general guideline for that?
So I think like there's the prompting handbook from, I remember the prompting handbook from OpenAI. Like, you know, you could do some few shot prompting where you know, if you tell it, you know, it's better to show it what, even if you have, like, let's say you wanted to produce a JSON schema, right? Like even if it's dummy, if it's a dummy number, as long as you give it some kind of the format you expect, it does better that way. So there are these like prompting handbooks. Chid, do you have a suggestion on prompting, particularly on AG2?
Okay. So what I would also suggest.
Sorry.
Okay. Yeah. So usually you can start, because if you don't know before you try it how capable one single model can do for your task, the simplest strategy is to just assume it can do everything and put all the instructions into one agent to begin with. So initially you can design just a single agent, right? Ideally, if you give all the instructions, it should be able to follow and solve all the tasks. And so depending on your task complexity, if your task is overly complex, often they will fail. You will find that they follow some of the instructions, but not others. And that's the time you know, okay, for certain functionality, you have to break it down. Instead of having one agent, you can look at what's already working and keep the working part in the original agent and move out the part that's not working to a new agent. And you can keep doing this, right? If it still doesn't work for the new agent, you can further break it down until it can handle one relatively simple task reasonably kind of reliably. And then you can connect the several agents back using the multi-agent approach. So I think that's the most natural way, especially because the model are also changing, and the model you're using may also be different from others. This is but the approach I said, I think is generally applicable in different scenarios. Another way you can try is you can try the captain agent feature from AG2. When you try the captain agent, it helps you automatically select the agents and generate the agents. And sometimes it just works magically, and some other cases it doesn't solve all the tasks. But at least you can look at what type of agents have been created and what the instructions are already there, and look at what's working and not working, and keep the working part and only change the not working part. And that's also a bootstrap, I think, to help you do this instead of from scratch. If you search a captain agent in the documented website, you can easily find some examples about it.
Yeah.
All right. Okay.
And I think it's worth looking at the reference agents because these are best kind of well-formed patterns. Yes.
Just a question with respect to prompting. What do you think about asking the LLM to come up with a good prompt? Just describing what you want and then having the LLM actually write the system prompt for you. What do you think of that approach?
Can have this. So
yeah. So that's what the captain agent is doing.
Yeah.
it's doing, that's part of the things Captain Agent is doing. Captain Agent is trying to analyze the task, decompose the task into subtasks, and then create a team of agents depending on the task instructions. And for the team of agents, it will decide the system problem for each agent, decide the tools to use for each agent. It can select both from existing library of agents and select tools from existing library, or create new agents on the fly. So Captain Agent integrates many of these ideas, natural ideas, into it. Yeah.
Yeah, and if it's the reason, plan, critique, iterate, right? Like these, the models themselves, the reasoning models are trained that way as well, right? Or post-trained. But yeah, you can leverage that kind of pattern, even having multiple, like here, I'm looking here, there's a decomposition critique, and then there's gonna be a way to break down what your initial prompt is. Yeah, go ahead.
Following the pattern we just already discussing, it's pretty easy to see how you can always go one meta level up and then use GenAI, use the agentic programming paradigm to improve. Are you using these techniques, GenAI, agentic programming, to improve the these frameworks already? Do you kind of let agents look at your own code, the framework itself, and improve that? Or is that something you're already doing?
That's the first thing I did when I created the first line of code of AutoGen. So before I created this multi-agent framework, I only, if you look at the history of the project, it's funny. The first functions I created was create code using language model and improve code using language model. I did try that to the own project, and find every time I apply that, I find a lot of problems with the code. But that was a very early code, and many of the suggestions were about some very simple things about the framework, and not the high level advanced capabilities. But that idea has never been kind of a way. So I always want to go back to that idea and keep using agent to refine the library itself. Yeah, I might try it soon again. Yeah.
And that might actually be an interesting, pattern, right? Like you have you create an advanced agent that is meant to write code for itself to grow. I just remember in the 3D printing community, right? Like you buy a bare 3D printer kit, and then you use it to improve the printer itself, right?
Cool. Okay. Please move on.
Yeah. Really good questions. And okay, the next bit. So I'll go through the tools, advanced tools. I think, let me see. Okay. So how do you integrate, tools with a agent? One interesting thing that I always find it interesting is like being able to connect to like Google Drive, probably something simple. And this is one of those questions of, what's the difference of having an ADK that is connected to the Vertex or the Google Workspace, and then something like this, because let's go through that. So there is a tool called Google Drive tool that is that your agent can use to connect to your Google Drive. So in order to do that, we have to set up our environment. We have to get our credentials to our Google Drive. This is how it will look like. You'll go enable your API. There's this thing you have to. It will produce your credentials, but you also have to create this Google Cloud project. I think it should be fine. You don't have to pay for it. And then let's go through that. Some settings in terms of, you have to give it like the app name of what you're developing that's going to talk to your Google Drive. Let me see, test. Aside from that, you have to set things like you have to add your test user who you're expecting to log, because this is just like dev access. Like you don't want to, not yet. This is not yet for public consumption. So I'm gonna use this email so that when I do the authentication, it's that Google Drive that it will have access to. What else? Yeah, so it will produce this secrets, keys. Yeah, okay, I think that should be done. That should be fine. Okay, you're going to get a JSON file. Once you do that process, it's gonna pop up. It will give you the option to download the credential. If you actually go to this data room research folder in the README, it has the links on how you could do that. Yeah, this one. And that was what I showed a while ago. This is just importing some of the Google credential libraries. Yeah, the important thing here is credentials.json. When you go to that folder, you need to have this. The token.json is produced when you do the OAuth. I will show you how that looks like. I basically have embedded that in the data room research main.py. So there's a function there that, yeah. This thing here basically loads up your credentials.json, and then there's another thing that it will produce it. Like I'll show you because I already have it here. This is what it will look like. I will rename. Yeah, so it will launch my various, sorry about that, stuff. Okay, then, yeah, that's the authentication. And then my folder will have produced, the code would have produced the token here. That wasn't there a while ago. And then, well, this is the full kind of agent that has access to the Google Drive. Actually, I might as well do that now. Show me 3 documents from my Google Drive. Oops, sorry. Yeah. That's why I was trying to ask it. Commands. Okay. Give me a moment. Use G Drive. Okay, please. Show me 3 documents from Google Drive. Yeah, we can see here that there's the advanced tool called Google Drive Toolkit that gets called. This piece gets executed by I have to manually say, okay, go display that. And these are some of the things that are inside my Google Drive. I can tell it to download competitors .csv. It calls the tool, the Google Drive download tool. Then it downloaded it there. And I did this because I was thinking this is an example of where you have a data room where you have information about I don't know, a startup or a company, and then you do some analysis, a deep research analysis afterwards. So that's the Google Drive toolkit. Let's see. So back to deep research agent. Let me go through that. Let me just close that. So this is the pattern. So you have this is a nested chat, right? So you have teams of agents doing the decomposition and the critiquing. Then there's the web surfer and web surfer critic when the web scraping kind of finishes and then summarizes the content there. How it looks like in code is that it's a reference agent, so it's already abstracted, which is quite interesting. It makes it quite easy. Yeah, so this is my very simple configuration. I'm just passing the LLM there, the LLM config, and then it nests through the different things that's happening. So I'm gonna show you how that looks like by restarting it. So okay, let's do that. Okay, what question, what topic? So I would like to know more about DeepSeek. Okay. Yeah. So these are just those blocks on the diagram a while ago, where it decomposes the actual, like the first ask into steps, and then it makes a plan on what to do in the internet, what kind of search queries does it have to send out, and then this is a scraping, web scraping. Okay, so we don't need to, I think, finish that, but I think that the delta that I kind of added in this example is how the deep research agent can interact with a Google Drive toolkit, an agent that uses the Google Drive toolkit, another agent that produces reports. So here I have a report writer. Yeah, basically produces Markdown and then saves it down in the folder. And this is the group chat pattern and one speaker selection method that I've kind of chosen here is that, okay, automatic, let the LLM decide how to orchestrate the sequence. So, compared to the Kaggle use case, right, wherein it's an ML lifecycle. So this one is a little bit more context dependent. So, for example, earlier I asked it to give me the content of my Google Drive. So the group chat manager called up the Google Drive agent. So when I typed I wanted to have more information about DeepSeek, it's the deep research agent that it calls out, and then it triggers the nesting of all the other agents underneath, and it's still going. Yeah. So another interesting pattern that is actually new that she wanted to call out is handoffs, the handoffs pattern. So you have sequential, you have automatic, and then you could define who the agent is handing it off to, following the patterns of the example in the repo is, you're in the hospital and duty of care is very, very precise. So yeah, it's the responsibility of the sender. So the sender must always know who they're handing off the person or the information to, or who they're calling to do the next task. And I think there's also other patterns where this is going to be built, wherein you have some kind of pub subscription, wherein it's the responsibility of the receiver to kind of call out hey, that's me. So yeah, but you can see it here on the README. I have a link there. You can see. Oh, it's not there. Actually, I think it was in the Kaggle README. The link was there. Yeah, a new way to handle transitions between agents is called the handoff. Yeah. So. Cool. Any questions? So far, it's still running because
it finished. It finished.
Yeah, there you go. Okay, I'm gonna tell it to please save the report. Yeah. So it volunteered to save the report. It produced this Python code, and then go ahead. DeepSeek research report should be somewhere. Yeah, this one. Yeah, it's simple markdown, but you can use libraries that produce Word document or something like that.
I was just going to ask a question.
Yeah.
It's very interesting. I guess like a couple of years ago, I'd be saying, oh yeah, wow. I guess my question now is, like when I think about wanting to achieve this kind of goal for myself, like, I guess the first thing I'd be tempted to do is drag and drop stuff into just like ChatGPT in our enterprise edition and do these sorts of analysis for me. Or even like now with the cursor and the latest, like you've got like a thing to look at Google Drive. I can kind of have cursor build me something to do that on the fly. And I wonder, is there a tension now between, you've obviously got an interesting agent framework here, but what's the pros and cons of using someone else's agent framework, whereas as opposed to sort of almost like an AI OS, where you just ask the AI to build this sort of stuff and pipelines on the fly for you?
Yeah, I mean, Chi, you might want to have your answer as well, because from a framework level, right? Like frameworks, like they're at the lower level of building those kind of platforms. I think this is a foundational thing from a product perspective, right? Like they're selling platforms, so it's actually quite useful. So there's going to be a different focus depending on the needs, like some bespoke stuff. Like for example, I want something on some of those things that I want on my laptop, right? I don't want secrets or something going to those places. So maybe that kind of granularity, or as a development tool, right? This is one. But yeah, it's really cool, the stuff that have been coming out. And I actually still go to, like, while I was developing this like demo, I would go to Claude or something, right? And just go back and forth.
Yeah. Okay. Yeah, very good question. There are several levels of answers to that. The first one is that the examples we show here are not the most advanced applications that we want to show. It's more like some basic examples we want to show people to relate to some of the familiar concepts. People know deep search very well nowadays, from ChatGPT, from Gemini. But the one thing people probably don't know is that at least 1 year ago, our open source community has used the AutoGen framework at that time and built very sophisticated deep research agent. At that time, there was no ChatGPT deep research, no Gemini deep research at all. It's more like made for example, the example was that investment, a venture studio used AG2 to build a team of agents to analyze a business idea and do all the search online and generate a very comprehensive report, deep analysis that can replace a human analyst work in about 1 week and reduce that to maybe several minutes. So that was at maybe even longer than 1 year ago. Yeah, that already happened. The deep research agent here is not that one. This one is even simpler, and just as an example of reference, to give others idea maybe how you could easily implement some of the very advanced features you see in other products easily by yourself and make all the customization you need, like Tim already explained. That are kind of sometimes you want some local customization that you want to, and you want to keep things to yourself, or you want to deploy it to some specific enterprise environment that your company has, and you can't directly use existing product to do. Yeah, so there are all sorts of reasons you want to customize. But again, this is more like what we're showing here is more like things that we knew how to do long time ago. There are some other much more advanced things that we didn't discuss, but I can give you maybe one example pointer to some of that. So again, if you go to the build with AG2 repo, could you go to the GitHub build with AG2?
Yeah.
Yeah. Okay. So if you scroll this down, there are a few projects. Okay, in the feature agent, in the first section, it's some project containing in this repo. But if you scroll down further, yeah, in that section, there was some link to more projects built with AG2, and one of them I think quite interesting is called CMB agent. Yeah, CMB agent is a much more sophisticated design for doing deep data analysis and research and so on. They could answer some very hard cosmology specific questions and using tools specific to that domain to answer that. And they have discovered some very advanced ways of making sure the agents generate a good plan and always follow the good plan. That's very hard actually. In many other cases, people find a lot of failures. But in this way, they're able to get rid of the human complete out of the loop and answer some of the very hard cosmology questions. And not only that, they further try that to other domains and found it also works very well in like analyzing financial data and social science data analysis and so on. And another interesting project I want to mention is, we'll go back to the previous one, called Psi Agents. Yeah, so it's another external project built by some. The previous one was built by actually some local people here from Cambridge, the cosmology lab from Cambridge. And the Psi Agents is done by another MIT group working on several different domains like protein design, material design, and semiconductor and so on. And they designed the Psi Agents to be a more. Psi Agent is one of the examples they built. Psi Agent is able to generate new scientific hypotheses that connect seemingly unrelated domains and refine them and generate a very comprehensive report that simulate how the human science team can do their work. Yeah, so these are some much more kind of advanced applications, but we can't easily explain that here because it contains many more components. But the fundamental building blocks used are quite similar to what we explained here. Yeah.
That's really helpful.
Yeah.
I guess that's a follow-up question then.
Yeah.
For some of these more sophisticated ones, and I've heard podcasts of people talking about replacing the human analysis with generating these things. Does the key question then become the evaluation? Like we can build a complex system that will generate a big report for us. You can say, right, that took 10 minutes and it would have taken humans 6 months to do it, so let's ignore the humans. How do we successfully evaluate the quality of the output? Is it actually as good or as useful as the humans do?
Yeah, fantastic question. So that's the question a lot of people ask. Let me begin with the example of the investment research example I mentioned from 1 year ago. So the domain experts here play an important role of serving as the evaluator. They need to compare because they need to compare with the existing alternative of not using agents. And the existing alternative they use is to hire a human analyst to do the job, often takes weeks. And when they switch to agents, they do need to understand how good the agent's work is compared to that. And because they are domain experts, they need to use this functionality every day. So they have a very good sense of what's good and not. And for example, initially they think that the agent's work can match maybe 80% of the quality of the human analyst. So then they keep improving it until they think it can match or exceed the human analyst quality. and then eventually they use it every day in production. That I think is the final test bed of this is really working, because this is a high stake kind of tasks. They make business out of it, and if they decide to switch, that means okay, this really meets their criteria. And similarly for this cosmology and for the other engineering domains, the people who are making these agents, they are the experts already in each relative domain, so they can make a good sense out of it. But when they try to generalize to other domains, then it's they probably also need experts from other domains to further look at it. So we can't easily claim if this works for cosmology and it can work similarly for other domains. So the claims for other domains do need to be more carefully investigated. And so this, so similarly, there's a chip design use case by NVIDIA, and these are like chip design experts. They also can understand, how good they can help their human analysts and so on. So a lot in all of these very advanced domains, we do still need to rely on the experts right now to do the good judgment. And for some other more commoditized domains or more everyday domains, we can easily hire maybe larger number of people to do the judgment. But for those domains, I think there's also a chance that we can design agents to automate some of the evaluation, like I mentioned earlier, because the common sense kind of judgment can to some degree be automated. And that's one area I think we could make a lot of progress. I think fundamentally, if we can make the evaluation part automated, then the agent self-improving can become more closer to reality.
And then eventually it will hit the question of, because the automation, right? So there's stuff like, you can have it like autorator, LLM as judge, and then you're gonna have to ask, like, but how can we trust the judge, right? And then you go towards, like, how does it compare to a human expert, right? So that kind of right now, like I think meta evals, they call it that, right? Even us humans would have an inter-rater agreement number, even if we're experts. They calculate some kind of inter-rater agreement as if the agent evaluator is one of us, and if it kind of similar, then kind of gives you some level of confidence. Right?
Do we have time for another question? Or?
Yeah.
I think that we have the last 5 minutes. Yeah.
We're already talking about limitations, or one limitation, and maybe an area of user improvement. Are there other limitations you currently see or topics you are working on in the context of AG2 or agent frameworks? Where are the main points?
Excellent. Excellent. Yeah. For me personally, because I come from the hardware space, like being able to use hardware efficiently in a disaggregated and heterogeneous way, right? Because right now, like its default is we use the biggest machine in the cloud, the GPTs of this world. So I think that's where you squeeze in like the efficiencies, right? Like some of them are running in on your phone, on your laptop, and then that disaggregated heterogeneous kind of way of deploying agents. I think that for me that's also going beyond the prompts. Like we were talking about this the other day, like because it's still going through the LLMs as text prompts, but is there a different representation that multiple agents can share that will be more efficient?
Yeah.
Efficiency in terms of bridging still a barrier to get to the compute power, or more like breaking it down to complete the job with smaller models?
They're kind of very tightly coupled as well, right? Like if we look at test time optimization, right? Like they're just putting more compute and making it think more. So if you're going to be efficient in thinking, then you can get to the end goal with less, right? But yeah, definitely power, compute.
Yeah, this is definitely the system side. There are a lot of optimization, even in the hardware layer. I think that's a big there's a big opportunity in that area. And some other areas like how do we design a really optimal agentic system, that how do we do the right way of decomposition automatically for a new task and do the optimal, build optimal system. Here optimal can mean many different metrics. It can, the quality is the most important, and then there's latency, cost, manual effort, and so on. So there's still a lot of a hard problem to do this, make this optimization automatic. And another one particular thing that I'm curious is about the how human kind of doing the reasoning and thinking to solve a complex task. I think the current agentic system is not very tailored to simulate that. I wrote a blog post to explain why I'm saying that. I think there's some misunderstanding about human reasoning, and those misunderstandings might prevent us to build a really strong agentic thinking and reasoning system. And yeah, feel free to check it. This is published in the AG2 website. I think that there are some good opportunities that we can learn from how human really works, how human reasoning works, and make agent perform stronger, much stronger. Even with today's models, probably we already have a chance, but we haven't really done that.
So you see a gap between
Yeah.
current reasoning
Yeah.
and the way humans reason, and you think by closing that gap, the system will improve vastly.
Yeah. Yeah.
Thanks.
Thank you.
Thank you very much for your time and for the really good questions. We hope you learned a lot. We're still around if you want to chat and chase around. Thank you.